Welcome back! In this section, we've discussed the roles we can employ when passing a message to a model, a system, user, or assistant role. We then used a system message to create a chatbot that adopts a sarcastic persona. In this lesson, we'll discuss a few more parameters that can affect the model's response: its maximum number of completion tokens, level of randomness, and the option to stream it. Let's begin with the tokens. As discussed earlier, OpenAI sets its model prices based on the number of input tokens, the ones we feed to the model, and the number of completion tokens, those the model generates. Both are capped to prevent users from inputting an excessive number of tokens and to stop the models from generating endless text. Still, it's essential to have additional control over the amount of text generated. Models often tend to be wordy and provide more information than needed. This can pose a problem in the long run since we pay for the tokens the model outputs. As a side note, this pricing only applies when using OpenAI's models through the API. In contrast, the ChatGPT platform is subscription-based rather than token-based, and you don't need to worry about the model generating long texts. All right, it's time we see the token parameter in action. Open last lesson's notebook. When defining the completion variable, keep the system message the same, but let's test the model with a different user message. For example, could you explain briefly what a black hole is? Define the maximum tokens parameter and assign it a limit of 250. Run the cell and print out the content. As always, our sarcastic chatbot gives an excellent response. Let's now see how it performs when we narrow the cap down to 50 tokens. This time we get a much shorter, even incomplete, response. So we need to be careful not to limit the model too much. I'll now revert to 250. Okay, what's next? Another parameter we'll use throughout the course is temperature. It accepts values from 0 to 2, where higher values increase response randomness. Although it defaults to 1, let's explore its behavior at the extremes. Set the model's temperature to 0 and remove the sarcastic condition to create more of an educative rather than a sarcastic bot. Let's again ask it to explain what black holes are. We obtain the following informative response. Let's now generate a new chat completion. Comparing the two answers, we find the new response similar to the previous one. Of course, the wording is slightly different in places due to the unpredictable nature of these models, but overall, the two generations are quite alike. Models with lower temperatures can be used when creating a chatbot for educational purposes, because the answers must be more academic and informative rather than creative. Okay, let's now increase the temperature to maximum and study these results. Well, we can all agree that this is far from helpful. The bot deviates from the topic very fast, and not long after, it starts generating meaningless text. So, such large temperature values are rarely helpful. I'll switch back to a value of 0. Another parameter that controls determinism is seed, like the seeds we fed to machine learning algorithms for reproducibility. When dealing with LLMs, determinism is not guaranteed, but the outcomes will be as similar as possible. You can experiment with this parameter at home. From now on, I'll set the temperature parameter to 0 and the seed to 365. I suggest you do the same to obtain results like mine. Okay, moving on. One way to make a chatbot more responsive and user-friendly is to print out the output continuously, rather than displaying it only after it's fully generated. The stream parameter allows us to achieve precisely that. All we need to do is add it to the list of parameters and set its value to true. Running the current cell and the following one, we find our variable is no longer a chat completion, but a stream object. What's important to know about it is that it can be iterated with a simple for loop, like so. Let's print the iterator in the body of the loop. Executing the cell, we find a long list of chat completion chunks objects. As their name suggests, they contain only a small chunk of the message. Now, within the for loop, let's try to print only the content of each chunk. First, access the choices parameter, extract its first element, then access the delta parameter, and finally, retrieve its content. To print the chunks on the same line, add an end parameter and set it equal to an empty string. Redefine the completion object and run the for loop. Look at that! We've managed to stream our text on the screen. How cool is that? This marks the end of our short introduction to the OpenAI API. I'm convinced you now find creating a chatbot with APIs much more fun and rewarding than merely chatting with ChatGPT. It gives you much more control over the responses and allows you to create some exciting chatbots. But wait until you see what LangChain has to offer. In the following sections, we'll employ intriguing projects using OpenAI's models and the LangChain framework. Until then,